Let's take a look at this problem. The age distribution of the Canadian population and the age distribution of a random sample of 455 residents in the Indian community. 455. But it was 455. Okay. In the Indian community of Red Lake Village are shown below. Okay, so we're given the categories, 4 categories. Then we got the percent of the Canadian population, and then the Red Lake Village. And we're wanting to see if the distribution of the percentages in Red Lake Village follows the Canadian population in terms of the categories, the ages. Now, use a 5% level of significance test claim that the age distribution of the general Canadian population fits the age distribution of the residents of the Red Lake Village. Now, I did this, already worked this problem using technology, and I've left all the information here, so we have to redo that part. Our claim is percentage is the same. Now H naught. Now step 1 was write down a shortened version of the claim, but step 2, come up with a null and alternate hypothesis. H naught has a probability for each category. So the percentages they give us for the Canadian, that's what we put down for H naught. P1 is equal to 0.072, P2 is equal to 0.136, P3 is equal to 0.671, and P4 is equal to 0.121. And then it tells us that H1 states that some or all the actual probabilities differ from those specified in H0. So H1 simply says some or all are different. Step 3. See if your claim matches H0 or H1. Our claim is that the percentages are the same, so it matches H0. Now the picture is always a right tail, so put alpha into the right tail. So I'm going to draw it. Now it's a chi-square distribution, so it's not bell shaped, but I don't draw them real perfect. Doesn't really matter. We got a right tail, we said. We're going to put the entire 5% in there, the alpha. And if that's 5%, this has to be 95% over here, because it all has to add up to 100%. Now we're going to have a critical value here. And this says, find a critical value. Ignore that table. Using alpha and degree of freedom is equal to k minus 1, where k is the number of categories. Well, we've got 4 categories, so our degree of freedom is going to be 4 minus 1, or 3. And, okay, I knew that was popping up in just a second. So let me minimize that. Okay. So let's go look this up. We're going to use alpha, which is 5%, and 3 in our table. This is in the chi-square distribution table. Now across the top is the right tail area. And our right tail area is the 5%. So we're going to be looking at a column that's 0.05. Here it is. And then we're looking for a degree of freedom of 3. So I go down to 0.05, I go down to 3, and I get 7.81. So that means this critical value is 7.81. Okay. Now we need, it says calculate expected frequencies. We already did that. So let me come down here. I'm going to label this as observed. We had our 47, 75. Try it again. 47, 75, 288, and 45. And we had our expected. Expected is 33, 62, 305, and 55. Now this says that we need to find a test statistic using this formula. O minus E squared divided by E. So if I actually if I just do this in a separate column, it might be easier. O minus E is 47 minus 33, which gives us 14. This one's 75 minus 62, which gives us 13. This one is 288 minus 305, which gives us negative 17. And this one is 45 minus 55, which gives us negative 10. Now I double check myself here. 75, 12, 17. Okay. Then we need to square it. So if I take my O minus E squared, so I'll have 14 squared, I'll have 13 squared, I'll have negative 17 squared, and I'll have negative 10 squared. I think 14 squared is 196, but let's see. $196. And negative 17 squared. Of course, anything squared is positive. 17 squared is 289. But we really need this divided by E. So I'm going to take that value I just found, and I'm going to divide it by E. So I'll have 196 divided by E, which is 33. I'll have 169 divided by E, which is 62. I'll have 289 divided by E, which is 305. I'll have 100 divided by E, which is 55. So 196 divided by 33. I'm going to take it 2 decimal places. 5.94. 3 might actually be more appropriate, but we'll see. And we got 169 divided by 62. 2.73. And 289 divided by 305. That gives us 0.95. And then 100 divided by 55 gives us 1.82. But we want to sum those up, because that's what this notation means. The sigma that's in front of it says we need to add those together, and that's going to give us our test statistic. So chi-square, our test statistic. If I add those together, let's see, 7, 9, 14, carry the 1, 17, 25, 34, 4, carry the 3, 8, 10, 11, 11.44. Let me double check that. 12, 14, 10, 17, 26, 34, 8, 10, 11. Okay. So that's our test statistic, 11.44, which falls over here because remember, you think of this as a number line. Here's 7.81, here would be 11.44. And this says if test statistic falls in a tail, which it does, it says we're going to reject H naught. And since our claim matches H naught, whatever we say about H naught is what we say about our claim. So that means we're going to reject our claim. Now I'm showing this one by hand for a specific reason. Not every calculator has the capability to, or doesn't have the function, chi-square goodness of fit. And so some of these you have to do by hand. And that's how you do it for this particular problem.